Yeah, let's go ahead.
Okay. Hi everyone. This is Naga. Welcome to another session of the SDE skills. So today's topic that we have selected is linked list. So this is one of the very quite common interview questions that have come up. So surprisingly, when I looked at it from the questions that I picked, I saw like these questions were asked like hundreds of times in the last 6 months. So these are uh, quite the questions which have come up very common. So I hope everybody have the handout. So I'm also going to oh, okay. I'm going to share my screen. Oh, oh, okay. Just give me one moment. I think it's not allowing me. Okay, let me try again.
I think Bhavesh shared already.
Okay. Are you guys able to see my screen?
Yes,
Yeah.
Yeah.
Okay. Am I audible or do you want me to speak up a little bit?
you are perfect.
Okay, cool. Thanks, guys. So the first question that we have is merging the two sorted lists. So here we are given two linked lists, and they are sorted. What we need to do is like uh, merge this two lists and in the sorted order. And here the condition we have is like the new list should be made by splicing together the nodes of the first two lists. That means like we don't really want to create a new list out of it, but rather use them to create the new list, which is sorted and merged. So, so there are a couple of examples that we can look at what we have on link on lead code. So if you see, yeah, even here we have only one example, but just refresh this. Okay. So if you look at this example, if we have this 1, 2, 4 and 1, 3, 4, the merged list would be like 1, 1, 2 from here, 3 from here, and 4 from here, and 4 from here. So the new one is also merged. New one is also sorted and merged. I think the question is pretty straightforward and clear. So anybody has any questions on the question? On the problem? So I'm assuming no. So any initial thoughts on how this can be done? I don't think there's any trick inside this. It's mostly like a must sort. Uh, uh, yeah. Any initial thoughts from anybody on like how this can be done?
You can use a recursion, right?
Oh yeah. We could use the recursion. Yep.
Yeah, like and the base case will be like if L1 is null, written L2, and L2 is null, written L1, and then try to compare the values of the first values of L1's node and L2 node. If it is less, then L1 dash next equals to use the same merge to least, and then just push that L1 to next in its passing parameter, and then return L1.
Yep.
And do the same thing for L2 in an else case.
Yep. Yeah, that's one nice approach using the recursion. Anybody has any other ideas like without using recursion, just to see like to the flow.
Yeah, I think the same thing we can do with the while loop as well, like taking the initial 2 pointers for the head of the linked list and then traverse through it based on
Mhm.
which list we want to move ahead with, and then that's how we keep on going. So
Yeah.
uh, yeah.
Yeah. I think that's true. I think it's pretty straightforward on like how we do it even during the merge sort. The
Mm.
only catch with the linked list that we have is like tracking the head pointer, right? Because in linked list, the challenge we usually have is like once we go ahead, we will miss the head, and we always have to make sure we track the head of the linked list. And some of the challenges we have would be like how the corner cases are a bit challenging in linked lists. Those are the challenges that we usually have. So, and those are the two approaches that suggested by I think Santosh and Sumit. That should work that should be pretty straightforward. So, does anybody want to try out any of these things? Then we can convert one to other or other to one. I'm hoping like maybe we should try the non-recursive first and convert it into recursion, or anyway is fine. Does any one of you want to try it out, or like anybody else wants to try it out? Okay. Um, if okay, so I can start on it. I'll I'll, I'll start with the non-recursive solution that Sumit suggested. Um, then we can see where we are with the time, and we can try out the recursion one also. Um, Sumit, so I'll go ahead and start with this. So
Sure.
yeah, one approach that I usually take, I think that I don't know if that's a trick or one easy way to handle the corner cases here is in the linked cases is like having a dummy node that usually helps in like when the node is null, or like when you are changing the uh, when you are creating the new um, new head. So in those cases, dummy node actually helps. Let me show you guys like how that works here and see like how it will help. Okay. So, so I'll just create one uh, dummy node which has nothing but a simple value. And then, like I said, the challenge we usually have with the linked list is like making sure we have a track of the head. So we just create one to track where we are as we proceed further. So now, so while L1 and L2 are not null. So what we want to see is like um, whichever is the least number of this, we want to make that as head, right? So if you look at this example of 1, 2, 4 and 1, 3, 4, in this case, both of them are same. So we can pick either of them. But in examples where uh, the list one, the first node of list one is less than first node of list two, we want to make that as the new head uh, the combined list, right? So I'll check here like if L1 in direction val, the value is less than, I'd make it like equal to, because we want to handle both the cases. L2 in direction val. So if this is less, so what I want to do is I want to make that as head. So what I do is like to make to make this tracking easier, I already have a dummy node. So I make the dummy nodes next is equal to L1, right? And then once I have taken this L1, so I've already considered like the first element of L1, and then I can proceed to the next node that I want to compare, right? So L1 is equal to L1 in direction next. And at the same time, I've got one node. So I want to check the other case, which is like if L2 is actually the value in the list node 2 is less. So that's also pretty same like what we did with L1. So next is equal to L2. And then in this case, L2 is equal to L2 in direction next, right? So once this is done, then we also want to move our tracking to our the tracking node to next. So and once we are done, so what we are doing here is like uh, uh, does anybody want me to go through the code with an example, or like do you think this is good?
But are we not considering the case when L1 is shorter than L2 or
Yeah,
L2 is shorter?
that's true, right? Yeah. So if you look at this example, this would work, but
Okay.
that's a good case. Yeah.
And I think in line 20, Naga, I think we need L1 and L2, right? I think by mistake, we suggest a typo, I guess. While L1 and L2, right?
Oh, you're right. You're right. L1 and L2. Yeah, we want to make sure both of them. Okay. So the condition that Santosh said, where like one of the nodes could be, one of the linked lists could be bigger than the other one. So when we compare, when we are just comparing with L1 and L2, once L1 or L2 gets null, then will be out of this loop. So in those cases, so I mean, like once we get there, it's pretty straight that from then on, it's nothing but the rest of the elements can be directly added to the combined list, right? So what we can do is like once we come out of this, I can say like track in direction next is equal to um, if L1 is not null, then I can add L1 or L2. So I usually like writing like this, but I believe it is clear, right? So what I'm trying to do is whatever is left, right? So once I come out of this L1 or L2, so let me take one example actually. So the condition that we are trying to handle is, so in case like in direction 5, in direction 6, so once we are done with this list, so you see that this while condition is exited because it becomes null, right? After we handle 1, 3, 4, it becomes null, but we still have this 5 and 6 left. So what I'm trying to do here is like if L1 is not equal to null, that means that I have few more items left in L1. So what I'm setting is like whatever I am tracking, that next is equal to the rest of the elements. And if not, that means like L2 has few more nodes left. So I put that as the next. So this would help us like handling the cases where we have one list which is longer than the other list. So once we are done, so here, if you look at it, so I have this dummy and this track is just pointing to the dummy initially. And I said like, so when we have started, we would have had like this, like a dummy which had just -1, or it doesn't matter actually what value it is in. So what we said is like dummy in direction next is equal to whichever is less. So that way now, which was track, dummy in direction next, whatever is less would have come here. So the new list would just be like the dummy. We should not consider dummy because we just created it to track the head, and the dummy dot next would be the head of the new list, which is combined with both of this, right? So that should handle all the cases, I believe. Uh, Sumit, I believe this is the approach that you are referring to,
Yeah,
right?
yeah,
In one
yeah,
single while loop, yeah.
yeah. Yep, yep.
And
So, Naga, I had one question. Like the idea of having a dummy node, right? Like, is there? Have you like observed some kind of pattern, like when to go with a dummy node and when not?
yeah, so actually, I mean, like after starting to use dummy, most of the cases, most of the places, wherever you think the head is changing, the dummy was helpful. So that could be like in these cases where we are combining these two and we don't know what is the head in those cases. And the cases where we delete the nodes, and it's possible that we delete the node, right? The head node. So
Mm-hmm.
it's where the places where we are losing the track of the head, those are the places that I thought like the dummy was helping a bit, so that you have something to start with, and then you can make your. So if you look at here, right, you have this L1 and L2. So we don't know which one to take until you actually look at the values in it, right?
Mm-hmm.
You could write a condition where creating a new node here by tracking all those values, but um,
Yeah.
making the dummy made it like very simple. Like I don't care about it until I'll handle those cases as any other case.
Right, right. Because earlier I have written the solution for this without dummy, where before while loop I make a decision like which node to pick out of tool list as a head node, and
Yeah,
then okay.
yeah.
So
I think the rule of thumb that I use is, sorry, go ahead. Yeah,
if you want to return the merged list, we need to
yeah.
return dummy right here, because track also we are changing, and if you want to return the merged list, then we need to return the dummy, right?
Sorry, your voice is a bit low. Can you?
If you want to return the merged list,
Right,
so we need to return the dummy, right? We have head in the dummy right now.
right.
So what is that number 41 will do?
What is that number 41 will do? So
41.
dummy is just like a dummy node that we created, right? It's not the actual node. So what we said is this track in direction next is where we said like what we selected from the two lists. Dummy has no value which is related to L1 or L2.
Okay, then how do we get the merged list head? Because for track also, we are changing the track to track.nest, right?
Right. So if you look at it, track is pointing to dummy.
That is
And
right.
we said whenever we found something which is less than one is less than the other, we are saying like the track in direction next is equal to that node.
Yeah, I understand that. If you come to number 30, line 36, we are
Mhm.
changing track to track.nest. That means we are
Right.
moving head of the track, right? Now here.
We are
So
moving the track.
yeah,
Yeah.
we are moving the track. Then
Mhm.
how do we return the merged list where we have the head of the merged list?
Dummy is also tracking that, right?
Yeah, that's what I'm telling. So
Yeah.
what is that number 41, line 41 will do?
So
Uh,
He
dummy.
has
Naga,
to return there on 41.
Naga, if you can write that before line 41, how the list looks like, that would be easier.
Yeah.
No,
Uh,
just trying to understand what it mean by dummy.next there.
No, he has to return that node. Just tell that.
right.
So,
Oh,
Naga,
So here,
you have a line number 14, right? You can basically show that line number 14.
yeah, 40.
14.
Oh, 14. Okay.
And basically add -1 in front. So it will be
Yes.
clear.
Yes.
Yeah.
I mean,
So
not the same list. Yeah, okay, output. Yeah, that
yeah,
makes sense.
so before
So
line
here-
41, the list would be look like this, okay? Because we started with extra -1 node.
Got it. Got it. So we are returning that now line 41. We are returning that node. Okay, good.
One, we
Next
are
node.
returning one. That's
this
the
is what
head,
we
right?
want to return, right? Yeah.
So,
Thank you.
so this is clever idea where, you know, just adding using Naga. This is a very clever idea where use extra nodes so that you remove a lot of complexity of what is head and, you know, what to return.
Yeah. Yeah. This actually helps in handling a lot of corner
Corner
cases,
cases.
like when head is one of the node is null. So in other cases, when usually handling like there's only one head and head is null, those are the cases where this dummy actually helps a lot. It becomes little intuitive, I think, after a while, but that's something that we can keep in mind. Like whenever you think that the head could change, we could think in this approach, like having a dummy helps in that process. So I have one more question where we did that. We can go in, we can reiterate on like how the dummy is helping in that also. So any other questions?
This will handle all the corner cases as well, right? Like
Oh
if
yeah.
the list is null and stuff like that, so it will take care of that.
Yeah.
Can you explain line 36?
In line 36. Okay. So so we have,
It needs to mute, I guess. Somebody's typing.
Yeah, I'm muting myself.
so we created a dummy and we have a tracker like this, right? This is, let's assume this is the track that we have, right? So this is pointing to this one. So when we look at this two lists, this is L1 and L2. Okay. So now what I'm saying is, whatever is less in between these two, I'm pointing my track dot next to, in this case, let's assume I took L1, right? Once this is done, so I want to move my, so what I said is like track in direction next is equal to L1. So track is pointing here, and then L1 moves to L2, right? L1 moves to the next. L1 head is pointing to this one now, right? So now this is going to be my new combined list, right? So far we have only created one, right? Did it make
Yeah,
sense?
makes sense. Yeah. Now you're
Right.
moving
So
moving the
now,
track to one more node. Got it.
right, L2, sorry, L2 head is here right now. So now I move it to here because L2 is actually less than L1 head now. So I mean, like, this is not needed for me now because I have L1 tracking here and L2 tracking here. But for the new list that I'm creating, the next is this one, right? So I have to keep link of this, whatever the new one is being created, like this link.
Okay. Yeah.
So I created this link and then, yeah.
Thank you.
Yeah. Okay.
Yeah.
Something went
One,
wrong.
one more thing, Naga. I just wanted to go a little bit basic on like maybe I also did that earlier, long time back. That when we try to merge the list,
Mhm.
I think you little bit touched that point where you are linking the nodes, right?
Mhm.
But I remember like maybe I implemented it some 6-7 years back where I was trying to create a new node and then assign the value of the node to that whatever the from the list, and then create a new node and create a new list altogether, which is not the right way of doing things. But you want to touch on that concept a little bit, like why don't we have to create a new node with a value and then create a new list altogether?
Actually, I think what we could create the new list completely, right? I mean, like that's nothing wrong. I mean that, but the question says like we need to make it like splicing together the nodes of the first two lists. They don't want us to create a new thing altogether. Otherwise, like it would be like a merge sort. No, I think even in merge sort, we actually don't create a new list, right? So
We
yeah,
use,
So
would it be
again, I mean, like,
valid
let's not
that
go into that, but yeah.
if
is
that
it
second line is not there, would it be valid to create a new list altogether? I mean, since it's a linked list, it's not needed, right? Like, because we can link the node and create a linked list, the
Yeah,
merge
we
list.
could do it. I believe then our space complexity would be O of n,
Right.
where we could have done it like with O of 1. Right?
Got it. Okay. Yeah. I just wanted to brainstorm on that point.
That's true actually. I think I did. I think maybe in the next problem we have some challenge like that. Okay, I forgot to return here actually. It's just like,
Oh.
yeah. So that did it. So we are like half an hour into the problem. I also looked at the solution Santosh mentioned, the recursion one, but I felt like this was like more intuitive for me to understand, and like for me to understand again, like I'm not too good into recursion. I'm still learning recursion. So Santosh, if you want to share the code, or like if you want to try it out here, anything is fine.
Well, this is fine actually. In fact, iterative is always good to do, because in recursion you use the call stack space and all that.
Right.
But yeah, we can quickly do it if you want to, or it's fine, whatever the way you want.
Yeah, I have only two more problems, but
Okay, so if you want, can you give me, or can I dictate you what exactly to be done? It's very small code,
yeah,
maybe 4 to 5 lines of code.
right. Good. I think I have seen that. So let's try it out. Like this. Okay. So what we do is like if
Yeah, the first thing is you actually see if L1 equals null,
mhm,
and then return L2.
we are handling the base cases first, right?
Yeah,
So the simple base cases. If
right.
L2
Equals null, then return L1.
equal to null, then return. So if you look, yeah, okay, I'll talk about that a bit later. And if not,
Then the
then we
first thing is L1 is L1 dash val. If L1 dash val is less than or equal to L2 dash val.
which is less than L2 in direction val,
Yeah.
then we do merge less.
Well, yeah, actually, you'll have to have that curly braces also, because you'll have to return L1 there. Yeah. And before merge to least, you will have to say L1 dash next.
So L1 is less, so I want to return. I'm already considering L1 direction next, and here L2 would be straight, right?
Yeah. But for
And
before merge to least, yeah, you just say you actually first say L1 dash next equals L1
oh,
in direction next, yeah,
next is equal
equals
to.
this, and then return L1 here below that. And
L1.
actually, you just copy the whole thing down for L2, then it works. And the else.
Yeah, copy the info also, but yeah. I think we want to do less than or equal to, right? In one of the cases, yeah.
Right.
That would be the same thing. So L2 in direction next, then
This will remain as
L1 in direction next, and return
L2.
L2. So
Yeah.
now we have
Run
L2.
it, it should work.
Okay, that's it.
Yeah.
Okay.
Yeah.
Awesome.
Thank you.
Okay. So first it showed like it's only faster than 8 or 9%. Now it shows 97%. So
Mm-hmm.
okay. So here what we did is like we handled the base conditions when one is less than whatever the base condition that we handled in the iterative approach at last, that was handled here. If this is less than this, then we know that we start with L1. L1 in direction next is equal to, we are finding which one of L1 next and L2 is less, and then creating the list. Okay. Yep. So that's good. That was quick.
On line 18, do we have to make it less than equal? Less than would be none.
Yeah, because actually he is taking care of that case, right? You know, when there are duplicates, you want to do that merging with the L1. That also works fine.
Yeah, without equal to also, I think it will work because it will go to the else part and it will be taken care, right?
Ah, you're right.
Yeah,
Actually,
both should be
else
fine.
is taking. Yeah, I didn't write a specific condition. Else should take care. Yeah, that's right.
If you
That's
submit
true.
this,
But then I think it won't be stable.
It won't be stable. I didn't get that part.
In the sense, the node actually, if they are duplicates, they might not have an order.
They would, right? Because we are handling it. Yeah, I think it would, because we'll do that always in the other case, not in the less than case. With other case, man, this is 100%.
Oh, that's lead code, so you don't have to believe that.
No, I'm just kidding. Yeah, I'm just kidding. But yeah, I think it would handle. In one of the cases we have to handle that equal to, right? Equal to doesn't matter whether we handle it there or here, right?
Yeah. This is okay for this case. Yeah, no problem.
Yeah.
so why didn't we need a dummy node here? Like, I'm just trying to, just curious, like just to have that discussion again. Like, why didn't we need a dummy node concept here?
I think dummy node concept in recursion is
Maybe it's not used.
Dummy node usually will be required when you are working in an iterative manner, right? Because you have to take care of that head. This is recursive. You usually have whatever you can use the same
Yeah,
pointer.
makes sense. Makes sense. Yep. Okay.
yeah. I'm still learning recursion, so yep.
Yeah. So recursion is it becomes complex always. So, but these are very standard things, you know.
Yeah.
I have done it earlier. I think maybe last time other Naga actually took that session and I wrote that. So that's what I know it, you know. Yeah.
Okay. Yeah. But good to learn both of these things. I think somebody who's like very familiar with recursion can make this one feels more easy, and the other one for for non-recursive people. So
Yeah.
good. Should we move ahead, guys, or any other questions?
I think, yeah, we should move ahead because there are complex things to do.
Okay. So the other one, the next question that I have is for adding two numbers. So here they have made the question very straightforward for us. So let me open it in the lead code itself. So. Okay. So here the question is like adding two linked lists. So adding two linked lists as if they are like the regular numbers, but they have given us a couple of conditions here, like which makes the question little simple, I would say. Rather than handling all the cases, they have given us like a lot of things for us to ignore and like focus on like the specific problem that we have here. So you are given like two non-empty linked lists representing two non-negative integers. That's a good condition. And then that way we don't have to handle the condition of sign and all these things. The digits are stored in reverse order. So the actual sum they wanted to do is like 342 plus 645. So the linked list is given like in reverse order 2, 4, 3, and in the reverse 5, 4, 6. Add the two numbers and return it as a linked list. You may assume like the two numbers do not contain any leading zeros. So that means like there are no leading zeros in front of the number, which would make it again complex. So that's also a condition that we don't have to handle. So it's pretty straightforward. You are given like 243, 564. You add these numbers, the first number and second number. So let me take this example here. So I'll take L1, L2. So what they wanted us to do is, okay. So is as simple as like add the first two numbers, create the first node, 5, 6, 7, add the two numbers, create the second node. But because these are like these, they wanted us to add like regular numbers. So instead of this becoming a 10, what will happen usually in case of 10 is like we take the carry to the next number, right? So if you're adding these two, 5 plus 2 is 7 and 6 plus 4 is 10. So we carry 1 to the next one, which is like 3 plus 4 is 7, and we carry that 1 here, right? Guys, is it clear, or do you want me to explain more with another example?
So can there be one number can be longer than other, or?
One number can be longer than other.
Okay. And
Yeah.
when it says that it doesn't have a leading zero, that means it is not 0, 3, 4, 2, that kind of thing, right?
Yeah.
Okay. Okay.
I think that's what they did. They made the question simple by removing all those special conditions, like not making it negative and all that. Otherwise, we would have to handle leading zeros.
Mm-hmm. Mm-hmm. So the
We take it as an extension to see like how we'll handle the leading zeros.
yeah.
Yeah.
Okay. So I think, yeah, it is simple unless there is one complexity that we need to handle is if the both lists are different length.
Yes, I think that they didn't give any condition that they will be of same length. Even two linked list representing two
I guess
non-negative.
I think yes. Now I'm rereading it. It is fine because they have given already in reverse order, so it doesn't matter actually.
Yeah, they gave it in the reverse.
Yeah, yeah. So I think yeah.
What happens? Quick question. Hello.
Mm-hmm.
Yeah. So what happens if instead of 3, 4, if you have 5, 5? So does it carry forward if it becomes more than 10? Instead of 7, 0, or it becomes 7, 0, 10 in the last. Instead of 8, if we get 10 or 11.
Oh yeah. So what would it be like? 1, right? So if we suppose like 4, 5, 6, 7, I make it like 5 here, right?
Yeah. Then it should overflow. I mean,
Yeah, it should become like this.
Okay. Thanks.
Right. I mean, like even in this case, that would be like 5 instead of what did I do? 2, 4. This becomes 5, and this becomes this one, right? So what we would get is 1007, right? So we want this one, right? So when we add these numbers, what we get is what's in the reverse order here. It is just a addition of the numbers. Okay. So is that question clear, guys, or do you want me to try with another example also? I think we handled the special condition that we need to take care of here. One was like carrying forward. The other case was like having the extra carry, right?
Yeah. I think this example is sufficient, right?
Yeah. I think so. So Okay, let's go ahead and see like any initial thoughts on like how this can be done. I don't think there's any trick here. I believe like again the tricks are like how you maintain the carry, how you maintain the heads, and how you maintain how you create this new list that we want to return. I believe like those are the concepts which are common in the linked list that we'll have to use here. So any initial thoughts from anybody? How we should go ahead with this?
Maybe use the same iterative way,
Mm-hmm.
like and use your dummy node, dummy head or dummy node, yeah,
Right.
and just the way we did for the last time, the iterative way, but this
Right.
time they're just adding the values, right, instead of comparing.
Exactly. Yep. Yep. I think that's how I picked it. So this becomes like a little bit of extension to what we did in the merge. There we were just merging it, but here like we are not merging that both of them, but we are kind of adding it, and there is a little bit extra on like how we handle the carry, right?
Yep.
Yeah. That's the
Slightly complex than the previous one, but yeah.
yeah, yeah. So that's the approach I had in my mind, and that's the approach that I wanted to go with. Uh, if anybody has any other ideas, let me know, or else uh, I can go ahead and start implementing it, or anybody else can do it as well. Any other ideas, guys? I don't know if this can be done in recursion. I'm assuming it can be based on what we did with merge, but I cannot think of it. Let's try after we do the iterative way.
Yeah, I think I've seen the recursive way also for this.
Yeah. Because based
Iterative
on
is
what,
more intuitive for me also. I try to avoid recursive.
yeah, I think at some point everybody has to get into that regression thing, but let's
But
see.
iterative is very safe to do, right? The iterative way, the way you explained about the dummy, because having a dummy node actually makes the code less complex,
Right.
Yeah.
I think
If you
most of,
don't use dummy node, then the code will be more complex, and then you will be thinking more towards the recursion side.
yeah, you have to handle many conditions there actually. So dummy is taking care of like, basically you have to handle those, um, there is a null, one of them is null, and one of them has like one single node. Those are the conditions that gets cleared out by having dummy. Okay, so I'll go ahead and start implementing it unless somebody wants to give it a try. If anyone wants to try it out, I can even help. Let's do this. Okay, so I'll go ahead and do this. So again, we have a dummy. So -1. So we need something to track it. So I usually have like a track, which is me. So now we know that we always have to, there is something carry that's generated whenever we add the numbers. So I'll just initialize carry to 0. So and then, so same like earlier, while L1 and L2, same like earlier, right? We want to make sure like there is some value there. So if L1 and L2, so then we need to add it. Earlier we were looking at if one is less than other and then doing some action based on that. Here we just want to add it. So I would say like L1 in direction val plus L2 in direction val plus and the carry, right? So every time we add a number, we want to see like if there is any carry from the earlier one, so that we have to add it and then act upon it, right? So in the first case, it's carry 0, so that is fine. So we got this one. And once we get the carry, then so once we get the total value, so the next what we have to take, the new carry would be this val by 10, right? So in this case we got 10. So the new, whatever will be carry forwarded is the is 1. So in case of if we got a sum as 17, when you do like by 10, you'd get 1 as a carry that we want to take it to the next edition, and 7 is what we want to create a new node, right? So let's here we will actually, we are not combining this, we are not doing the addition in this list 1 or list 2, but rather we are creating a new list that we want to return, right? So I'll create a new node with this sum, which is like temp. I'll create a new, and that would be the val. Yeah, I mean, it would have been intuitive, like if I calculated these values before, but because I've done that before, I'm just avoiding those things. So we are creating a new node. So in this case, we have like 5 plus 2, which is 7 here. The val is 7 here, and there is no carry for it, right? Because 7 is just like a single digit number. So the carry is again 0. But I want to create a new node with this 7 value. So I created a new node with 7 value here. And then now here, this I'll be tracking using the dummy head node that we created, right? So I say like track in direction next is equal to the new temp that I created. And then, so here it's not like I've selected L1 or L2, right? So here I'm selecting, I've added L1 and L2. Earlier case, it was like I've selected L1 and L2 and I only move forward with one of the linked list. So now I have to move forward with, I'm done with 5 and 2. So now I have to do with 4 and 7. So L1 is equal to L1 in direction next, and L2 is equal to L2 in direction next, right? Uh, so did I miss anything? So again, like the return value is like we have dummy. So somebody,
We need to see length of the L1 is less than length of the L2, then we need to make the remaining.
yeah, somebody, I think your voice is very low. Yeah.
If L1 is 3 digit and the L2 is 4 digits, we need to take care of that also, right?
No, right? Because L1 and L2 uh, both have to be valid for us to get into while condition, right?
After that,
Like earlier. Yeah,
suppose
after that, right? Yeah, that's one condition that we need to handle that is still pending. And also, what else?
Carry only case.
everyone,
Yeah,
all,
yeah.
yeah.
There's only carry, right? Both of them could be like 3 digits, but the carry, there is a carry case, right?
So Naga, why do we need dummy node here? I mean, I think head is something which we are creating just one time, right? So do we really need a dummy node, or we can just have a tracking node and that can also we have to make first time calculation as a head node. So that's why the dummy node is
Yeah.
help. Okay.
Yeah.
So
Otherwise,
we have to assign head to that first time calculation and then move it to next. Okay.
Yeah, if we don't have dummy, like again, we need to have an if-else condition in the while
Right.
loop.
Yep,
Yeah.
yep, makes sense. Yep.
yeah, those are the things actually. Whenever you create a new head, you change the head and all these things. So, right. Okay, so let's handle the other cases where we have a carry. So even if there is a carry, so I could write a complete new while loop to handle those things, or update this while loop to handle that. So let me try updating this while loop. and see if that makes sense. Otherwise, we can write the new case. So what I'm trying to do is, so in any case, right? So either of these cases, then we want to do this addition, right? So, but when we do this, um, whenever we find that L1 has some value in it, we'll take the value of it. If L1 is null, we add 0 to it. Does it make sense?
Yeah, right.
Right. So same here. So when L2 is not null, I take L2 value in it. If not, I add 0 to it. Right. And that way we don't have to handle those null cases.
That's right.
Make sense?
Carry
Okay.
anyway, it has 0.
Yeah, carry anyway, it doesn't matter, right? So as long as there is a carry, then we'll take it forward. So same here, right? If L1 exists, then we do L1 in direction next. Otherwise, we'll just keep L1 as is. Make sense, guys?
Yeah, I think I like this line 32 where you have carry also as one of the parameter in the or condition. Otherwise, I used to do it like outside the while loop after the with the same logic. But the if at the end the carry is remaining, then we have to take care of that as well.
Yeah. Actually, I wrote a while loop, extra while loop initially when I did. Then I saw somebody in the discussions, they said like that could be handled here. And like heavy use of this kind of conditions, like it's called ternary conditioning, right?
Yeah, yeah.
Yeah. This is actually pretty useful in this kind of cases. Like when this is null, you do this. If it is not, you do this. And
Yeah,
here
the
also,
one
like,
list is ending and other one is not, and that kind of situation.
right. So this should handle all the cases where any of them could be small and there is only carry on it, right? And then our return would be dummy dot next. Okay. I think I have one bug in it. Can anybody?
What is there at line 40? L1 equal to L1, then L1 dot next. What it means?
So this is a ternary condition which is as good as writing L1 is equal to.
Yeah, I can understand that. I know the ternary thing, but what are you trying to check here?
So if L1, I'm saying like or, right? In this case, what happens is like if any of these things are valid, which is like L1 is not null. To check the first condition, right? L2. Okay, let's make it like this.
Yeah, basically
L1 is not
maybe
null,
not.
but L2 is null.
Yeah.
Right. So what I want to do is like I want to go to next condition only if that is not null. Otherwise, it would hit the null handling exception, right? We don't want to move forward. So in case like
Then you
this
have
one,
to check L1 not equal to null, then go for L1 next, right? L1 equal to L1, it will be always same, right?
no, this is the condition, and this is what is getting assigned to L1. So it is like the condition is L1 is not equal to null. So this is the condition. If L1 is not equal to null, I do L1 equal to L1 in direction next. If L1
Oh,
is
okay,
equal to
okay,
null,
I got it.
yeah,
Oh, in C++ even null also taken care as a false.
yeah.
Oh, okay.
You don't have to do that in C++. Yeah.
So
Yeah,
if you
that
go
in
to
Java they have explicitly specified that. Yeah, sorry, somebody was saying something.
no, that's fine. So only I was trying to add, like if you don't do that over here on line 40 and 41, you will have to add another while loop,
Right.
in case if you still have L1 and L2 remaining, and if the condition on 32 was L1 and an L2, right? So
Right.
that you are avoiding here.
Yeah.
Is the bug that check on carry should be not equal to carry not equal to 0 on in the while condition?
No, that's also taken care in while loop, right? So if it is
It's a,
0,
I think it's a 38. Track is not moving to next, right?
Yeah, I think track is not moving to the
yeah, that's
current
right.
one.
That's right.
So
Yeah.
this track is equal to that.
If we don't do this one, then why we need a while loop? I thought the if loop, if condition would be.
Yeah, if condition. Yeah.
Yeah,
If,
but if you do if condition, then that's like a constant time, right? On this one, let's think about we have one list that's only one node, and the second list, let's say have a lot of nodes. Then we have to iterate through them all one by one.
not necessarily only with the first node you'll have to do if you have a carry.
No, right?
But no, the second one, L2, is not node, so you carry one by one.
Right.
Just have a carry only one. What are you trying to say at the end?
L1 we have only one, and L2.
L2, yeah, we have like many of them.
Yeah, 1 in direction, 2 in direction, 3 in direction, 4. So
Okay.
what we are doing is we are doing this calculation by making it 0. We made it like by using this while condition like this, we made it look like this one, right? Right. So by doing it like is equal to 0, though there is no value there, we are adding that. Rather, we could have made it like 1 plus 1 is 2, and after 2, I think we still have to go through all this, right, Leon? It's not like we are just we are creating a new list here. It's not like we are using the existing list.
Oh, okay. We'll create a new one. Okay.
Yeah, we are creating a new list. So we'll anyway have to go through this and create that list.
Yeah, even if we reuse it, and let's say the list number 2 at 99999, then eventually we still need to walk through them all, because 9 plus whatever be 10, right? We have to carry it over.
Yeah. So
can this be done without a new list? Like, can you reuse one of the lists? Is that possible?
Yeah, it's possible actually. Yeah.
It is
but you'll be modifying.
It is possible, I think. Yeah.
Yeah, if we do that, but then we are modifying the input what we got, right?
Right. I mean, we don't want to do that. Yeah, unless they say like make L1 the sum or something. Yeah.
It is unpredictable because you might end up modifying either L1 or L2 depending on which one's longer. And it is totally unpredictable. So creating a new list is always better in this case.
Yeah.
Because at the last the carry will be also there, so you might have to create that at the end in certain scenarios.
That is an additional creation.
Yeah. Okay. So I think this, I know this will work because it's again. Okay, it seems to be consistent, but yeah, cool. Any other questions, guys, before we move forward with the next one? Any other suggestions or anything? Okay, so if there are no other questions, then I'll proceed to the next one, which is little different from what the pattern that we have been doing. This is more of a pattern where we are using a dummy node, combining these two lists and operating on this two lists at a time and creating a new list. So that's a little different, but it looks like that's also kind of a very common question that comes up. There's some trick in it, but yeah. Okay, so I'm moving ahead with the next one. Okay.
For the previous example, quick question. Do you have to delete the dummy node before you return? Does it create memory leak or no?
I think this, because that's a local on the stack, right? Once you come out of that function, it gets released, right? It's a local, I created a struct variable there. So it's created on the stack.
I don't have it on the screen whether there was a new there or whether there was
No,
no
there
stack.
was
Thank you.
no
Okay, thank you.
Yeah, yeah. That's right. That's a good question, actually. Right? What are we doing with that? That's not much of a memory, but yeah, that's a link.
One quick question on that. What if one of the nodes L1 or L2 is null and not the other one? Would it be better to do the check before we get into the while loop? Because I think in that case, we'll be going through the list.
Yeah.
One list, right?
That is true, actually. So that's one optimization that we can do, like check for one. If one of them is null, just return the other one, right?
Yeah.
Yeah, that is true. That's a nice optimization that we could add.
Okay.
Optimization that we could add. That's right. Yeah. Okay. So the next. So moving ahead to the next question. Okay. Okay. So this question is, you are given a linked list and then create a deep copy of that list into a new linked list. So, but the condition here is like, along with this list, and a typical singly linked list, what we have is like a list and a pointer to the next node. And then that's how it goes on, and the last one points to null, right? So here, along with the next link, it also has another extra pointer, which is pointing to some random node in the linked list. Okay, I think I'll show with an example. Lead code has some examples, so I can jump on to that. Okay, so this is the linked list that we have, which is like, this is the node. Typically, you will have it like a node, next, 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 and next to null. And but linked list also has another link, not like a AA linked list where it has a pointer to the previous node, but this is pointing to some random node in the linked list. Okay, could be anything in the list. What we need to return is a full clone of this node. Create a complete full clone, deep copy of this complete list, and return. Does it make sense, guys? Or it's just like the input is same and output is same, but just that they don't want to use the same thing. Make a full copy of it and create and return it. So
we are having another variable in that structure of node where it is pointing to some other node.
Yeah.
Is there already there in the list, right?
Yeah, which is already there in the list. Yep, that's right. Yeah. So double linked list, we have it to the previous node. Here they have one more node which is pointing to some other random node. So
right.
that doesn't make it easy, because in a doubly linked list case, you know, like what it points to, the exact previous node. Here it is pointing to some random node, which adds to some complexity here.
Yeah.
And what is a random node over here?
Random node is just like, instead of a typical single linked list, it's just like it points to one next node, right? So the 7 is pointing to node 13, which we call as next because that's how we track it. But there's one more node which is pointing to something else along with the next node. So it's like each one of them is pointing to two different nodes.
Yeah.
One is like our regular next node. The other is like some random node.
So like the same doubly linked list concept, right? Instead of previous and next, we have next and random.
Yeah, next and random. Yeah, yeah. I don't know, because doubly linked list, we know exactly like it's pointing to the previous node, right?
Right. Yep. Yep.
Here it's not like that.
It's not like that. So we'll have to find out the point.
Yeah, it's like
where we're going to
interchangeable
point.
with all the stuff. Yeah.
What is that we'll do after this? I'm not understanding output.
Yeah, the output is create a clone of this linked list and respond. That's it.
It's a deep copy.
Yeah, deep copy. Yeah. So it's like you have to have in the new one also, you have to have like the new pointers to the next and new pointers to the random.
Oh, okay.
And the values are not unique, right? Are they unique? I mean, I think that makes it tricky here.
Values are not unique. I don't think it matters here because we are not dealing with values here. I mean, like it's just like, I don't think it matters here. Why do you think it makes it tricky if values are unique versus duplicate?
Because like I can actually maintain a random pointer, like for a 7, like what is a random pointer I can make? Like I'm just thinking, you know, maybe I can maintain a map, but what if there are like multiple 7s? Like I cannot maintain a kind of a brute force. Like I'm thinking, you know, how do I maintain a random pointers so that like, you know, next iteration in my cloned copy, I could map the random pointers, right?
But when you are having a map, actually, first of all, I don't think it's a brute force, it's an optimized version. But when you're having a map, you could actually use nodes as a map.
Yeah.
Using a value. So in that case, duplication won't be there a problem.
But like, let's say if there are 2 7s, I mean, how do you still store it as a map? Like for us, like, let's say in the first example, like, oh no, let me take a random pointer. Like 13 is a random pointer is 7, right? So 13, you'll keep it as a key and a value as a 7 as a node, right?
No, I think
so
key
I think 13 is also a node, and then its value would also be the new node of.
If you're doing a map, you know, first what I would do is I would run through this main list, okay, and put that in the map as a key, okay, and for that corresponding, I'll create another node which will be my node for the new list. Okay, so now even if I have 2 13s, I will still create 2 different nodes for my new list, right? So then I just have to look for how they are pointing to the random ones using the original list and just point the same way you're looking at the map.
Okay.
Yep. Maybe in a very high level, it's yeah. When you implement, it will be more. There will be a lot of tricks to be done, but that is what
I think that means like you don't put a value in a map, but you put the address of the node to
That's
the
correct.
map.
Yeah.
So the address, you know, even the value is duplicate, but the address of the node are unique.
Yeah, you can put the address of the node itself. Yep. Yeah. I think that's one approach of like using a map of and maintaining all this stuff and recreating the clone. That would be like O of n space complexity and O of n time complexity, right? We run through it once and that's all I believe.
Right. But that would be a quick way of coming in an interview. But you might have an optimized version if you are actually more focused on not using any space.
Yeah. I think that's
will be more tricky.
Yeah, that's the trick part of it. Like not using any auxiliary data structure or like using the extra space to come up with a solution like that is what. Yep. Any ideas on like how that can be done? I felt like this is like you have to know the trick in advance, or like I don't know if we can come up with that kind of a solution on the first go. But
I know the trick.
Yeah, that's that's the thing. I think I don't know if somebody will be able to come up with that, but I'm trying to see, like, as a group, if someone can think of that that kind of a solution, that trick in the question.
Yeah, I think Sandeep said, right? He has a trick, so yeah, he could go ahead.
He said he knows the trick already.
Yeah, but yeah, if you know the trick now,
Maybe
like,
answer. Why don't I give head to the new node?
Sorry, Hari, I think your voice is somehow low, actually.
Or
Can you
my
please?
laptop problem or something. So why
Okay.
don't I give head to the new node? I know it is a dumb answer, but we have a head to the original list, right? Whatever I already having.
Mm-hmm.
Give the head of the original list to the new node, then it automatically copy the entire list, right?
No, what we want to do is like create a new clone out of it. That's the question, actually. Complete deep copy of this one into a new one. So it's like the pointers also have to be like a new pointers. When you say deep
Oh,
copy,
okay, okay,
it's
got
not
it.
like you're pointing the pointers.
Oh, I misunderstood that.
I don't know if there's the deep copy concept exists a lot in C++, but I don't know how that is in Java and other places.
Java is also like we actually create a separate node, right?
Yeah. But I heard a lot about deep copy and shallow copies in C++. I'm not too familiar with Java, so.
Yeah, but a shallow copy in such case won't be possible even in Java, because you can't copy the references, right? You have to point to the new node what we are creating.
Yeah. Okay, so I think we might want to. Sandeep, do you want to explain the solution that you have in your mind, like the thing that you were thinking?
Sure, I can try actually.
Yep, sure. That would be great.
So what I'm thinking is, let's say, let's take a first example. So we have 7, 13, 11, 10, and 1. So we create a new node immediately to the 7 after 7. So we kind of like 7 will map to a new node with the value 7. And the new node 7 will point to 13. So we create a new nodes in between 7 and 13.
Okay. As you talk, I'll just have it here. So that way, 7 in direction 13, 13 in direction 11,
10 and 1.
Okay. Actually, I have a diagram also, but yeah, let's go through this. Yeah.
Yeah. So I'll iterate through the linked list, and can you start in the next line? At current is 7, so I'll create a new node 7. Then I'll actually move my current node to the next, and or a new node to the next, which will point to 13. And 13, I'll again clone the 13 node. Then I'll clone the 11th node. Then similarly, like I'll clone all the nodes and connect it accordingly.
Okay, so basically you created one more dummy of everything here.
Yeah. So that's one iteration. And in the second iteration, I'll start with 7. Then again, like from the root.
The randoms are still random pointers, right? That you have
Yes.
to take care.
So because I think thank you, like, you highlighted that 7 with that single quote. So 7 is a cloned one, which doesn't yet have a random one. Random values are still null.
Okay.
So only these actual nodes, which are 7 without a single quote, has a random pointer now, right?
Okay.
So in the second iteration, what I'll do is I'll start at 7. 7 random pointer is null, right?
7's random pointer is null. Yeah.
So I don't do anything. I'll move to the next step. Let's say, maybe I'll take 2 pointers. One is maybe like which is pointing to 7, and other one pointing to 7, like kind of a dummy node or a clone node. Yeah.
Okay.
Okay. Since I do not have anything, 7 random is null, so I'll move to next. So 7 will point to 13 now. Okay, and the clone pointer will point to 13 hive, like clone one. Like maybe you can move those. In the next, can you move the next? Keep that way. In the next line, can you move keep those arrows and the next line. Yeah. So next one will, next arrows, can you point it to like 13 and 13 hyphen? Yeah. 13, yes. Yeah. So at this point, 13 random pointer is pointing to 7, right?
Right. 13's random pointer is pointing to 7. Yeah.
Yes. So at this point, I can say like, maybe like, let's say 13 is pointer name is head, and maybe 13 cloned one is like, maybe H and H1, right? So I can say like H dot random, sorry, H dot next dot random is equal to which is nothing but like, 13 dot next is 13 clone, right? So I need to set the random pointer of the 13 clone. So I'll say like, 13 dot next dot random is equal to 13 dot random dot next, which will be 7 clone, right?
Okay. So whatever the random pointer of 7.
Yeah, 7 dot next is 7 clone.
Right.
So that way like 13 will point to 7 clone now.
Okay.
Maybe if you could write that line, that would make easy for others.
Okay.
You can say like, maybe that's like a H and a H1, or I don't know how to give a proper naming convention.
Let's make it, what we want to do is,
we want to say like maybe head dot, head dot next random. Yeah.
Direction random is equal to
equals head dot, sorry, this is, yeah, head dot next, sorry, head dot random. Random, this will point to next. Random dot next. Random arrow next, yes. So this will map 13 clone to 7 clone.
Yep, and that you do for all of them.
Yes. And in the third iteration, I can break the chain.
Okay, that's the second iteration. And the third iteration, you change the next pointers of all of this.
Yes.
So that would be like head direction.
Head dot next is equal to head dot next maybe. Yeah, and maybe new head. Yeah, that's a new head, which is a cloned one, right?
Right.
New head.
Clone in direction next.
Is equal. Yeah, clone dot next. Maybe yeah, we may need to handle some null conditions.
Yeah. Clone in direction next in direction next, right?
Yeah.
Okay. So I know, like, for somebody looking at it for the first time, it's a bit tricky, but I think once you understand this 1, 2, 3 steps, it would make sense. So I can share a diagram that I was creating to explain this. I'll try if that will make sense for people. So yeah, whatever Sandeep said, I've actually put it in a diagram. Here we have written the code for it, but I think let me try. I think if you have the premium account, Solutions also has like one of the approaches, they explained it. But let me show what I have. How do I? I'll stop sharing this one and share a OneNote that I have where I have written this.
Yeah, I think even in discussion also one diagram is there.
Oh, is it? Okay, that's good. Actually, I didn't find anything. So okay, let me see. Are you guys able to see my screen or?
No.
No. Okay. I lost this button to share the screen.
So there is that share screen, right? Yeah, on the Zoom meeting.
Yeah, my Zoom is.
Maybe then Bhavish has to give you an access.
No, I completely lost the tab which allows me to share. Actually, I don't know where it. Oh, okay. It's share
It might be on
screen.
that. Yeah, status.
Yeah, I have it now. Let me give it one moment. Yeah, share. Let me see. This is also something I do, so may not make much sense. So I'll also check how it is in chat.
Yeah, but
The
this
chat diagram better.
good. Yeah, the way you have done it for the second, third, they explain exactly the steps what we discussed with Sandeep now, right?
They explained it in the what was there in the chat.
No, I didn't see the chat. I think someone was saying about that.
Yeah, if you can open the link.
Oh, he has shared in the chat, it seems. Yeah.
Okay.
I can find a first comment if you will expand, read more. There is a code and a diagram next to it.
Yeah. I think it has it. Let me see what I have. I think I wrote it for the complete thing. So, are you guys able to see my OneNote?
Yes.
Okay.
Yeah.
So if you look at this, so this is the list that we are talking about, the first one, where we have this white pointer is the next pointer and the blue line is the random pointer, right? You see like 7 is next pointer is 13 and 7's blue is null and the blue is the random pointer that we have. So as first step, what we did is for every node that we have, we created a clone node, just the clone node, the next clone node. That is simple, right? Just create a node in between for everything which is a clone. So like Sandeep explained, we just created a clone. And this clone, if you look at it, it doesn't have a random pointer. It just have a next pointer, right? So we just created a clone in between. So the challenge of creating the clone is only with the random pointers because it goes in haywire, so it's not that easy to track. So once we have this clones, what the condition that we did, if you look at it, what we did is the clones random pointer, the seven doesn't have a random pointer. Now we have to fix the random pointers of this clone. So the 7's random pointer is equal to the original's uh, random pointer next. So if you look at, if we want to fix the 7's random pointer, we fix the 7 and 7's next is all good. So we want to fix the 7's random pointer. So what we do is 7's original random next is the random of 7, right? In this case, it doesn't have it's null, so it still points to null. But when we are trying to fix random pointer for 13's random pointer is the 13's original's random pointer
Which is
next, which is like 13's original random pointer is 7 and that next is 7. So now the 13's random pointer becomes 7. Did it make sense, guys?
Yeah, so the clone 13's random pointer now points to 7, which is also in the clone list.
Yeah. So that's what we want to create, right? The idea is like if you look at this, we have to create an exact clone of that one, right? So we have to copy the next pointers and we also have to copy the random pointers. So first thing we are trying to fix is the random pointer. So to find out what is the random pointer of 13, so that's the approach that we use. 13's random pointer is 13's original's random pointer next. 13's original random, 13 is the original node. The original 13's random pointer is 7. 7's next is the random pointer of 13. So that's what we did here. And once we did that step, then it's just like fixing the the next pointers of everything. Like 7's next, we want to change it to 13. 13's next, we want to change it to 11. And 7's clone, we want to change it to 13. 13's clones, we want to change it to this one.
So we are rewiring the
the
original one and the new one also.
Yeah. So I know it might still be a bit confusing. So let's try to do it in the code as one more thing.
Are we modifying the original list? We are not creating a new one, right? We're creating nodes in between and rewiring them.
Right. We are not modifying the original list. That's the goal of it actually.
But
we
in
don't
the
want to modify.
transition, we are modifying it. But when we are in the process, we are modifying it. Right. At the end, we actually realign.
Yeah, at the end we realign. That's true. We are modifying it and then realigning it to the original. Actually, lead code has like if you try to modify the original one, lead code was throwing an error saying that you are actually changing the original. I think I saw some error like that.
Oh, okay.
Okay, so with that said, I think the original was like this 1, 2, 3, 4, and the random is like this. So in the second step, we created a clone for everything. I think this is also clear. So second step, we created a clone for everything. And then we are fixing the random pointer by saying like the random pointer of this clones is the original's random pointers next. So if you see like one dash random pointer will be one's random pointers next, which is exactly like what we want, right? So it went like that. And then we fix the complete list. So Sandeep or anybody wants to code it?
So this is an elegant solution, but it's not thread safe, right?
Why do you think it's not thread safe?
It means while we're mucking around with the list, nobody else can use that list.
That's right, actually. But I think we'll make a full, I don't know if we will use the reference of the list to do this. You're right. Yeah, ideally, like we don't want anybody to use the list.
I'm saying in the real code, unless you put a lock on the structure, you know, it's not safe, right? Someone else can get a completely wrong result.
You're right. Yeah, that's true. As you are doing this, then somebody wants to use it, then they'll get some random things in the code. Yeah, that's true. That's a good observation. I think we should tell in an interview. Yeah.
Yeah, but in that case, you will have, there is no other way to use than map only, right? You can do that only with map.
Yeah. We'll have the trade-off would be like we'll have space.
Extra space, yeah.
We discussed about that map solution. I remember, like, you know, there was some complexity with the map solution when you have multiple values, or even if you use a map with a key as a node and a value as a node.
Okay, we can try and see. I haven't explored the map solution. I didn't make. So the way we want to do map would be.
Because let's say if you take like 13 and 13, and 7 and 7, and 7 is pointing to the first node, and the next 7 is pointing to the second node.
So are you taking the same example or like
a different example? Like,
okay, different example. Okay, let me clear this off. Let's have it there. Actually, it will helpful. It will be helpful when we code. But yeah, can you tell me the example?
We can take 13.
13.
13 pointing to 13, which 13 doesn't have any random pointer, and second 13 doesn't have any random pointer. And now we have 7. 7 is pointing to first 13.
As a random pointer?
Yes, as a random pointer.
Okay. So I don't know how will I do it.
Maybe just right below that, you know.
Yeah, maybe you can just say like above 13, you can write 0 or null, something, and you can write in.
Yeah, I think I'll just put what its random head is on this one. Okay.
Yeah. No, there it's n. Like 13 is not pointing to anything. You can say n.
Oh, you're saying like on this one you write
Yeah.
30, so it's
Yeah.
pointing to 13. Okay.
And you have after 7, like you have one more 7
Okay,
at the
since
end.
it's a
7
duplication.
pointing to, yeah.
Okay, and after 7, I have one more 7.
Yeah, that is pointing to 13 again, which is like second one, 13 quotes.
Mm-hmm.
Yeah. So, I mean, how do we do this?
So you are saying like the first list is on the line number 30, right? The original one. So you have 13, 13, 7, 7. Is that the way you're saying?
Sorry, I didn't get your question, Santosh.
Yeah, so on line 13, so this is the list which is like 13, next is 13, whatever that quotes, right?
Mm-hmm.
Or is it a different, it's a random pointer? I didn't
No,
understand that.
yeah, 13 is a node. All these like 13 quotes is a node. I mean, 7 and 7 quotes are nodes.
Mm-hmm.
But
nodes in the sense?
They're just like a linked list nodes.
Okay.
If you just ignore the random pointer thing, like 13 is just a node, which is pointing to one more node whose value is 13. And that second 13 is pointing to one more node whose value is 7. And similarly, 7 is pointing to one more node whose value is also 7, right?
Okay.
But
okay.
And 13 and both 13s doesn't have a random pointer, but this the first 7 is pointing to the first 13, and the second 7 is pointing to the second 13.
No problem. I got it now.
Yeah.
So what you can do, first thing when you create a map, okay. So now you on the line 13, the first 13, what you have, okay, you put that as a key for the map, right?
Mm-hmm.
So all of these, like the on line 13, whatever the nodes are, they will be keys of a map, okay. And then you will map with another node in the map, right?
Okay, in this case, 7 is pointing to 13. So 7 will be 7 node will be a key, and a 13 will be a value, right? Correct?
No, actually the map should contain only the root actual input object to the actual cloned object, not the random pointer.
Yeah, random pointer, we can fix that later. The way we are doing it for your the earlier one, right? The same thing we have to do here for the randoms also when you want to map them. But here first you create the list. The way you are creating the list, when you are adding one more node in between the two nodes. So you just create a map with all the key nodes of the original list. And when you are mapping, you will map with another node, right? So you actually create another node corresponding to each and every node of the original list, right? So then again, when you are actually looking for the random, you go to the key and look for the random. So you know where the random is going to be, correct? In the map, you can find that. So the random's value will be the value of the random for the clones node. Exactly the way you are explaining in the line number 2, okay?
Mm-hmm. So how are we creating the clone node first? Like first linked list, like are you creating new nodes between 13 and 13? I mean, between.
No, you're just creating when you are actually creating the map, right? So when you actually put that in the key, you just say new node and then put the value.
Naga, could you make those? Could you write those? I mean, just.
I have shared a code that's in Java. I have shared that code into the chat. If you can bring that up, it will be easier.
Okay.
Okay. Sure.
In chat of this only.
Yeah. Oh, you actually pasted it here. Okay. Okay.
So for you, you'll have to unshare and then look in the chat because you won't be able to see the chat.
No, I'll just paste the code here.
Okay.
Let me do. I think I'll not lose it. So I'll paste it. Yeah, okay.
Correct. So here what we are doing is that in first, yeah. So that's basically the map that we create, and and the temp head is just for the iteration purpose. And yeah, ABC is the dummy node, which we will return the results, right? And in the first loop, we are iterating. You are just creating a clone, and that line, yeah, line number 27 is to create the clone, and yeah, and you move the dummy to the next. But in map, while we are putting the original linked list node, and the value will be the corresponding clone.
Yeah. Putting the original
node, and the value is your corresponding the cloned node.
Okay, the new dummy that you created. Okay.
Yeah, and that's how. So this first iteration, we are just adjusting the next pointer. It's like we are creating a clone, and the next pointer will be pointing to the correct the cloned one as well, right? And in next iteration, you just go and fix the random pointers for all the dummy nodes that we have created. So yeah, in the next iteration, when you see the line number 36, it checks, it goes and picks the dummy's random pointer one, and if the temp.random is null, you assign it as null. Temp is basically the original list node, and otherwise you look into the map for the temp and you get its random pointer, right? So random pointer will again be pointing, I mean, the value of that will be again the dummy node created corresponding to the temp.random actual value, right?
Oh, okay. You go and get the.
So in the first loop, when you're creating the clone list, it's a separate list altogether. You are not following it's not the same approach as like the second step of the previous step, right?
No,
so you're creating a new list altogether with a clone of the list, and then in the map you have the original list and the dummy node.
Yeah, yeah, I think that trick is only needed when you don't need to use the extra spaces of map. If you're using map, you can do away with that, right? So it's like 2 iteration, you create a separate list, and fixing the random pointer will happen in the second iteration.
Right. Yeah, I think by having this extra space, you are saving that multiple iteration of though it's a big of n iteration, but multiple times we have to go and detach the list and all those things, right? So this method will save those kind of steps.
But in that case also we are only having one more iteration at the end. Anyway, we have to do 2 iterations.
Yeah. There we are doing.
I think that the tricky part was like the 29th. So when you're putting in a map, we need to put a dummy. Yeah, no, okay.
Right. So there you have to create a node actually.
Okay. Yeah. You created a original and dummy in the map first, and then in the second iteration to fix the. How is the dummies next getting fixed?
Yeah, dummy equal to dummy is not next, right? So whenever you are, so next is generally, so, okay. So at this position, it's like next pointer of this dummy is, as of now, is null, because the node that we have created on line number 27, it's random as well as next, both are null.
You're right, yeah.
Right? So, and then you move to that pointer, but in next iteration, when you come, you are fixing its dummy.next, right? So in line number 27, you will pick again from the old list or the original list, you will pick and you will create a dummy node which it will point to.
You're creating a temp value, dummy indirection next is equal to.
I think that is 27 and 28 is just creating a new clone list.
So when you do in a new linked list, you create a node and then move to that node, right? For the next one. So that is what you're saying, yeah?
Okay. Makes sense.
If you understand deeply, actually, if you clearly understand the previous approach, this one also kind of same. Instead of using the map, in the previous approach, we are trying to utilize the linked list node things, right?
Yeah, exactly.
Exact same thing. Instead of having a separate memory, we are trying to inject the cloned node in the main map itself. It's kind of exact same. If you think the previous linked list as each pair as a key value, that will be exact same as the map you created here actually.
That's right. Yeah.
Yeah,
That's right. Yeah.
The
Yeah.
only third additional step is splitting the linked list from the original and the cloned one. That is the only one extra step we are doing there in the previous approach.
Yeah. I think that's the reason one iteration extra from this one, right?
Yeah.
So until here, it's the same. And the third last iteration that we have in the previous approach is like the splitting that we don't have here. Yeah.
But here you are using an extra
Extra
data
step.
structure.
But like somebody mentioned, right? In a practical sense, if this is being changed and if it is not thread safe, it's like you are changing the original, right?
Yeah, that's true. But we could always have a dialogue with the interviewer, right?
Yeah, yeah, yeah.
What actually he wants.
Yeah, yeah. And if this is just if what we are passed to the function is not a reference but is a copy of the original one, then it's again a different case, right? If it is a reference to the original, what's passed to the function is a reference, then you're also working on the same copy that is passed to you.
But here you are not modifying. When you're using a map, even if it is passed as a reference, we won't modify the original list.
Oh yeah, in this case, that's right. We are not modifying, but in the previous approach, we were modifying, right?
Yep, yep.
Trying to reuse it.
Yeah.
Trying to reuse it by changing its next point.
But then we can always say, when we are using this function, we can put a lock.
Yep, yep, yep.
That we can always say that.
Yeah, yeah. I think the point is always talking about all those trade-offs and explaining the different things, right? Yeah, that's good. That was a good discussion.
Absolutely.
So now that we have the code for using the map, do we want to look at the code for the previous approach, or I think that's all the questions I have. Like I only had 3 questions today.
But if you have it easily accessible, I think you should walk through. That would be great instead of writing it.
Okay. Yeah, yeah. I mean, writing it also would not be.
Okay, then
Yeah,
everything's fine. But because we still have some 15-20 minutes, right? So.
Right, right. So, what do you guys think? Should we write it?
Yeah, you can. No problem.
Sandeep, since you have the trick, do you want to try or?
No, I mean, you can go ahead. Sorry.
Okay. Cool. So, first thing is actually first step is to create. First step is to create the clones. So in linked list, always good to, it's always like, we don't want to lose the head. So I'll put like a track is equal to head. And then while track, what I want to do is like I'll create a new node star temp is equal to new node direction val. So we created this dummy temp node. So now we want to change the pointers of the node. So temp in direction next. The new nodes next will be our track next. Right. So track in direction next. And now I want to change the tracks next is equal to the temp. So now I've inserted this temp node that I created with the same value in between the actual head and the next. So then I move my track should be my next node in the original list, right? Track is equal to track in direction. My next would be temp. So next. Did it make sense, guys?
So you're creating temp as a new node.
Yeah,
And then
created
you're
a new
adding
node.
next to tracks next. Okay. And track next is pointing to temp. Okay.
Okay, now that I lost track of my head, I say like again track is equal to head. So now we are fixing the random pointers. So back to head. So what we said in the condition there was like head in direction next in direction random is equal to head random next, right? So track in direction next in direction random is equal to track in direction random direction next, right? So in this case what we have done is like there is a 7 node in between, so 7 so 7 in direction the duplicate 7 so random is equal to 7's random in direction next. So in this case 7's random is null, so this would fail. So I would say like track in direction random should have a value. Only in that case I do this, otherwise I'll just point it to null. Okay. So once I'm done with that, so probably I should move my track to the next original. It's equal to track in direction next in direction next. And the third step, I think by this time we have fixed we have the copy nodes in between, and the randoms are also fixed. So now we have to
Yeah, just one thing on line 56. If track dash next is null, do we need to take care of that condition?
track that next is equal to
Track dot next is always a random, the cloned one. So we will always have track dot next at this point of time.
Yeah, that will never be in.
Yeah, track. We are always created a duplicate for the track. If track is true, track dot next will be true.
Okay.
Yeah. The third step is fix the next pointers. So now we have track is equal to head. So track clone is equal to the track whatever head or track. I think anything is fine. Track in direction next, which is we have the original here, and to track there's this one, and for us to return the clone we still need a lobster clone track clone. Okay, so while so track, so we lost the tracks next, so we have to fix track in direction next is equal to track in direction next in direction next. So since we have one duplicate in between, so we're just making like next in direction next. So that should be good. So now the track clone also should do the same. Clone in direction, next in direction, next. That should do it. I believe here we should check the condition here. This track clone could go to
Clones next can be null here.
yeah. So okay. So track is equal to track in direction track in direction next. So I want to move the track to the next.
Next is sufficient enough, right? Already you broke the link properly in 66.
67, yeah.
Sorry, 67, yeah. So
yeah, I think that should do.
Oh, but still you okay, but still you have to assign track equal to track next, I believe.
Oh yeah, I've just changed the tracks next. So I have to change the track. No,
yeah.
Track is equal to track dot next in direction next, right?
Yeah. Just track that next, right?
Because track dot next is already.
Okay. You have to jump, right? Yeah.
Yeah, track dot
Same
next.
thing from code.
Same thing for clone. And since that's all.
Can we not combine second iteration and third iteration in one loop, one while loop? Is that feasible?
Second iteration and next iteration. Probably yes.
No, if you
we
combine,
cannot.
Yeah.
No, the random pointer will be messed up, I think so.
Yeah.
Okay.
Yeah, maybe there might be some optimization, but yeah.
I think
Because
all
here
the
we are only
clones needs to be created even for the random pointer to work, so we cannot combine them.
Oh, yeah. Because once we lose the next pointer, we will not know the random. So
It should be isolated. Yeah, makes sense.
maybe I think we can give it a try, but yeah. Okay, I think that's all I think that should do. Let's get direct type line 45.
Oh, perfect.
Yeah, okay, there is something wrong.
Yeah, it's only the base case condition. Yeah, just look for that null at the very beginning. If head is equal to null, return null.
Okay. Okay.
Yeah.
Okay, guys. So I think that's all I have. Apart from this, one of the I wanted to cover one more, but I was not sure if that would be enough time. So one more pattern that we have with the linked list is the two-pointer approach. There are like a lot of problems with two pointers. One is like finding the finding the node, the nth node from the end, finding the circle, finding the intersection point. All of these have like a different approach using two pointers. So that is one more trick with the linked list, like using the dummy node to handle these conditions. That's another trick that's there. Maybe we can cover it in some other point, but that's another thing to look for.
Okay.
Yeah.
Wanted to ask, is there any other question which will use this similar kind of trick that we did in this one, is to put intermediary nodes in between while we are cloning?
I don't think so. I haven't seen any similar questions. Clone a graph, it seems.
Yeah, clone a graph. Yeah, actually, that is one. If you have an adjacency list, and then if you want to clone that, a deep copy, then it uses similar one, but not the same, because in the adjacency list you will have a node and a list of nodes, right? Which are its
Correct.
It's pointing. So when you have to create that, you will have a list to be created, and then you will have to, the way you are using a random pointer over here, but there will be a list. So that will be slightly tricky, but yeah, can be done.
But how can we do graph using this? Because graph already will have the list of nodes, right? How can you have the another list? How can we differentiate the original children versus cloned children?
Original children, so you will have to still do a deep copy. Okay, so you'll have to create two different adjacency list. So when you are creating a two adjacency list, you will use a similar approach, right?
Then we are disturbing the actual structure of the graph node.
No, the original will be the same. It will remain as is, right? You will create a clone of that for each and every node. And then when you look for the original node's adjacency list for a particular node, which are its neighbors, right? And then you actually create another list in the clone adjacency list for a particular node pointing to its nodes. In fact, I would say slightly it's almost similar what he has done. Yeah, Naga has done for the last one, almost similar.
Okay.
But
Because
it's a good thing to try. That is also a very common question they ask nowadays.
Yeah, surprisingly, this is a very common question actually. This is like one of a kind. It's not like very a specific pattern or anything like that, but surprisingly, this is a very common question. Seems to be even in the last 6 months.
Yeah.
So,
but it's not difficult to come up with both the solutions. They are not so easy. Yeah.
Right.
Yeah.
Okay. So that's what I have, guys. I mean, like, if you have any other questions, I'm happy to answer. Or I'm also going to upload the solutions, whatever we have discussed, into GitHub. So a little later, so you can also refer to that.
Yeah, that will be helpful.
Yep. Yeah. I'll do that right after.
Yeah. So that was a very good session.
Thanks.
Thank you. Thank you, Naga. Yeah.
Bye.
Naga.
Thank you.
Bye, Naga. Thank you.
Bye-bye.
Thank you, Naga.
Yeah. Bhavesh.